In today's video, we will discuss a resolution of vector. Normally, in my previous video, I have discussed short part of topics that are tricky and that need a lot of explanation. So I have explained that. In today's video, I am going to start topics in full. So I am starting from resolution of vector. First, we would define what is a resolution of vectors. Resolution of vector is basically the process of resolving, the process of splitting, the process of dividing a vector into its mutually perpendicular components. So we would define it like this: the process of splitting or dividing or resolving a vector into its mutually perpendicular components. Perpendicular components is called a resolution of a vector. Whenever vectors are splitted, whenever vectors are resolved, whenever vectors are divided into its component, like this is a vectors and I am resolving this into its component, and these components are mutually perpendicular. If this was a full one vector, let's suppose I am saying this is a full vector and I am resolving this vector such that this is splitted, this is resolved, this is divided in such a way that the component obtains are mutually perpendicular. These two are mutually perpendicular. There is an angle of 90 degree, so they are called mutually perpendicular component. So whenever the process in which we split, in which we resolve, in which we divide a vector into its mutually perpendicular component, that resolution, that splitting, that dividing is called resolution of vector. Let us consider a case scenario in which we take a vector f. Let's consider whenever a vector is taken, let's consider a vector f. Whenever a vector is taken, so that vector taken vector makes an angle theta with the x-axis in anti-clockwise direction. A vector which makes an angle theta, which makes an angle theta with x-axis. Whenever vector is taken, so that particular vector, it will make an angle theta with the x-axis, and that will be in anti-clockwise direction. So whatever I have written in this sentence, I am transforming that into a diagram. So let's take a vector f. We are taking here a vector f. So this is a vector f. Now in the second part, this vector make an angle theta. So this is angle theta. And this angle theta is taken with x-axis and its direction is anti-clockwise. That was the scenario. Now, in this topic, we discuss here that we will resolve this into its component. So some part of this vector is with x-axis. So that is the part of f, and this is with x-axis. So that is called fx. And the other part is with y-axis. So that is the part of y of f, and that is with y-axis. So here these are basically the fx and this is fy, and they are mutually perpendicular because these two vectors have angle of 90 degree. So that's why we say the process of splitting or dividing or resolving a vector into its mutually perpendicular component. This was the first vector, and it was resolved in such a way that it gives us two vectors and they are mutually perpendicular. It is basically opposite of addition of vector, and addition of vector we add vector to get a resultant vector. Here we divide a vector to get component opposite of addition of vector. This process is opposite of addition of vector. Like we say, this is first vector and this is the second vector. So this is the resultant. This is the first vector f1, this is f2, and this is resultant r. Here we divide this resultant r into its component. So this is the opposite of this. Now our next goal is to find fx. We have to find fy and theta. So this is, if we observe, we inspect, here is a triangle is formed, and any triangle, the side adjacent to theta is called base. So fx is the base here. The side opposite to theta is perpendicular. So this is perpendicular. And the side opposite to 90 is called hypotenuse. So we have a formula for some people have curly black hairs through proper brushing. It's a formula that there are certain people in this universe, they have curly black hair and they used to comb their hair with proper brushing. This sentence, it gives us the ratio for sine theta, for cos theta, and for tangent theta. So sine theta, this sum is show us sine theta. Sine theta is equal to, people show us perpendicular and have show us hypotenuse. So sine theta is equal to perpendicular divided by hypotenuse. Sine theta is equal to perpendicular divided by hypotenuse. In this diagram, perpendicular is fy. So we will plug in here fy. So sine theta is equal to fy divided by f. We require here fy. So fy, which implies that fy is equal to f sine theta. So the first case, fy is found. Now we would find and our second, we would find fx. So cos theta, curly is show cos, black show base, and hair show hypotenuse. So cos theta is equal to, black means base and hair means hypotenuse. So cos theta is equal to base, that is fx, and hypotenuse is f. So fx is equal to f cos theta. So the second, fx and fy are fine. Now This is a right angle triangle. So in a right angle triangle, hypotenuse square is equal to base square plus perpendiculars. We will come to that later. Now if x is find, if y is find, we would find now theta. So hereby tangent theta, through means tangent theta is equal to perpendicular divided by base. Perpendicular divided by base. So tangent theta is equal to perpendicular, here in this triangle we have fy and base is fx. But here we need theta. So we would shift this tangent from left hand side of the equation to the right hand side of the equation. Or we can say multiply by tangent inverse on both sides. Multiply by tangent inverse on both sides. So tangent inverse into theta is equal to tangent inverse fy divided by fx. This will cancel with this, so theta is equal to tangent inverse fy divided by fx. So fx is fine, fy is fine, and the theta is fine. Now we are basically finding that what is the resultant of f. What is the resultant of f? We would again draw that diagram. That was basically f. This was theta. This was fy and this was fx. So in a right angle triangle, Pythagoras theorem says that hypotenuse square is equal to base square plus perpendicular square. And this is a right angle triangle. A right angle triangle is a triangle in which one angle is equal to 90. So this angle is 90 degree. So in a right angle triangle, hypotenuse square is equal to base square plus perpendicular square. If you are going to memorize it, this is, here is a formula for this. High blood and this is pressure. So high means hypotenuse, blood means base, and pressure means perpendicular. So hypotenuse is f. So f square is equal to fx square plus fy square. If we take under root on both sides, so this would cancel with this and it will become f is equal to fx square plus fy square under the root. So this is the resultant. We can also find tangent theta or this by another method. If you people inspect, this is the first vector, this is the second vector, and this is the resultant. So the sum of the individual vector is equal to the sum of the resultant vector. By head to tail rule, this could be the first vector, this is the second vector. When these are added, so this is the resultant. So we can say f is equal to fx plus fy by head to tail rule of vector addition. Now square on all terms, square this one, and this one. So it would become f square plus f square plus fy square. And if we take square root, so it would become, this would cancel, and f is equal to fx square plus fy square. So this can be also found by this method. Now we are finding tangent theta by another method. Tangent theta, we have fx and fy. As we inspect that fx is equal to f cos theta and fy is equal to f sin theta. These are the two equations for fx and fy. Now we divide equation 2 by equation 1. Divide equation 2 by equation 1. Whenever equations are divided by each other, so left side is divided by left side and the right side is divided by right side. So it will become fy divided by fx is equal to f sine theta divided by f cos theta. This f would cancel with this f. Sine theta divided by cos theta, that is equal to tangent theta, or tangent theta is equal to fy divided by fx, or theta is equal to tangent inverse fy divided by x. So same as the result here. We can prove all these equations by another method, and that method is that will end of today lecture 2. This is f, this is fy, and this is fx. If we take the magnitude, so there is no need for direction. This is theta. This is fx, so this side, these two are parallel and their length is equal, so it will be also become fx. This is fy, and these two lengths, if we inspect, this length is equal to this length, and here this length is equal to this length. These both lengths are same. So if this is fy, so it would become fy. And if this is theta, so it would also become theta. Now you remove this triangle from here. So the remaining triangle is that triangle. This is basically this is base, and this is hypotenuse, and this is perpendicular. Again you apply those angle, so it would be derived. Like we said, sine theta is basically is equal to, some people have perpendicular divided by hypotenuse. Here perpendicular is fy and hypotenuse is fo. So fy is equal to f sine theta. Cos theta is equal to curly black here, base divided by hypotenuse. So fx divided by f. So fx is equal to f cos theta. Similarly, Pythagoras theorem is applied. So hypotenuse square is f square is equal to base square plus perpendicular square. If I summarize my today video in a nutshell, first we define what is resolution of vector. Resolution of vector is the process of splitting or dividing or resolving of a vector into its mutually perpendicular components. It is basically the opposite of the addition of vector. In this we have taken a vector f which makes an angle theta with the x-axis and anti-clockwise, and we derive what is fx. Fx is equal to f cos theta, fy is equal to f sine theta, and theta is equal to tangent inverse fy divided by fx, and f is equal to fx square plus fy square under the root. It was all about today lecture. If you like our lecture, please encourage me by liking, by sharing my video and subscribing my channel. Thank you. Inshallah, I will keep on uploading onward full lecture as I have delivered today. Thank you.